Remember, derivatives are easy and integrals are hard. Integrals are more difficult because you have to think through, well, what form is this integral that you're using? How do we determine what that is the derivative of, doing derivatives in reverse? So take a look at this example, for instance. The integral of dx over x squared plus 8x plus 25. An initial reaction might be that, well, this could be the natural log form, 1 over a function. But the problem is, you don't have the derivative of x squared plus 8x plus 25 anywhere else in the integral. So it must be some other type of form. Well, let's see what we can do with this. Well, can you factor x squared plus 8x plus 25? Well, no, that's not factorable. But maybe there's something else that we can do with this. Let's try this. Let's try maybe completing the square. We've got x squared plus 8x, and then we have plus 25. Put a little space there. And think to ourselves, what do we need to put here in order to complete that square? Well, in order to complete that square, we need to have plus 16, and then compensate with subtracting 16. And so, therefore, that would be the completed square. So, therefore, we can rewrite this integral as the integral of dx over, and then x squared plus 8x plus 16 would be the equivalent of x plus 4 quantity squared, and then we have minus 16 plus 25 would give you plus 9, and of course you could have from the beginning just simply split up 25 into 16 plus 9, but now it looks like something that maybe we can get our hands on. It looks kind of like another form we have, the arctan form. So let's see how we could do this. So the arctan form would have a plus 1 right here. But let's go ahead and factor out that 9. I'm going to factor out that 9 from the bottom there. And then that becomes 1/9. And I've got dx. And then I've got x plus 4. I'm going to write it as over 3 because that's what that is. 3 squared, you're really dividing by 9. And then the 9 divided by 9 would give you plus 1. So now it really looks like the arctangent form. Again, think of that as u being x plus 4 over 3, and then the proper du would be 1/3 dx. You don't quite have the 1/3 there, but we could always put it there. So here's how I'm going to rewrite this. I'm going to rewrite this as, we got dx over x plus 4 over 3 squared plus 1. And I'm going to go ahead and put the 1/3 there. 1/3. And then we have the 9, the 1/9 that's already out front. And then if we compensate with 1/3, we're multiplying by 3. So now it is the arctangent form where u is x plus 4 over 3. The proper d was 1/3 dx. And up front we have 1/3. So it is 1/3, 1 over x plus 4 over 3 squared plus 1 times the proper du, 1/3 dx. And we have 1/3 arctangent of x plus 4 over 3 plus c. So it's really a matter of recognizing what form it is and doing the proper adjustments in order to create the proper form. And always remember that you could double check if you've done your integral correctly by taking the derivative and seeing if the derivative brings you back to where you started.